Testing, testing, testing. Hi there, guys. My name is Rohan Beve, and today we are going to be talking about electricity. We're going to be talking about what is electricity and, well, not what is yeah, that's actually it. What is electricity? We're going to be talking about what is electricity today. So, in order to learn about it, we don't need to go to like lightning or stuff. We just need to go not to the size of an ant, but we need to get into the molecular level, the size of an atom. So let's start with part one, the atom. So as we know, we can't see an atom like this. So let's enhance it a bit. So we're right now using the Bohr model. This is mostly an inaccurate design for the atom. It's way completely different than this, but for explaining electricity, this will do for now. Okay, so let's look at the parts of an atom here. So first we have the nucleus here, which is composed of protons and neutrons. And the things that are orbiting it are called electrons. Okay, and we're going to be talking about electrons a lot more because these little buggers are what create electricity, hence the name electron. Okay, so first, as we see here, these will move around, just they will just orbit around faster and stuff like that, all composed inside an atom. And the plate and the space between the orbits, let's call these the shells. So these will envelop the atom. Okay, now we have an atom. Now what? So now we have an atom. Now here is some stuff we need to know. So what an element here is, let's say carbon, right? An element is made up of how many protons are in its nucleus. As we can see, you might not see it from the camera there, but it shows here 6 protons, which means that it'll have the number 6 here on from its nucleus. Okay, and if it's the same metal, the same type of metal or same element, okay, the proton thing will stay the same, but there could be more neutrons or possibly more electrons. Now, for electricity, we're going to be explaining about the electron side because that's going to be useful, increasing and decreasing, okay? That would be super helpful. So now, let's look at this, okay? So as we see here, these protons are creating a positive charge here, and the neutrons are creating a negative charge here, basically creating a sort of stable ground, putting it to net zero of the atom, putting it to its lowest state of energy, which is called the ground state, okay, when it's all like this. But we can change the balance of the electrons. So say if we added less electrons, so let's just scrape these off, then that would mean that as we see this atom, the proton side, which means it will just basically positive charged. And if we gave it more electrons, then it would become negatively charged, okay? So now that we know about that, so now let's keep one thing straight. So as we know, electrons are light, okay? Super fast. And that's what makes electricity and makes an electric current. Now, let's see here. So now from now on, we're gonna color code these guys, okay? So when an atom is positively charged, it's called a positive ion. When an atom is negatively charged, it is called a negative ion. And when it's equal, net zero, when it's equal, then it's just called an atom, which will be represented by this circle thing. But I'm pretty sure we'll figure that out, right, guys? So now let's go on to part 2, the valence shell. Not the valence, the valence shell. Okay, so as we see here, so here we have the atom, right? And we have the rings around it. each ring can hold up to a certain amount of electrons per ring, such as the middle one will have 2, then 8, then 18, then so on and so on. Okay? So, and each of these rings has a capacity. So this one is 2 and this one is 8, so as we can see here, so when moving, okay, there's like again a specific capacity amount around it. So that means when any new electrons are added in, that means the electron will go to the nearest spot nearest to the nucleus. So it'll go to the nearest available spot near to it. Now, if the outer shell, the final shell of the final layer orbit of the atom is fully complete, filled with electrons, then it's in its valence state. So it's in its valence shell, and all the atoms this valence atom has are valence electrons, okay? Which means that now the atom is generally stable, as we can see here. So now, let's move on to chapter 3. Static electricity. So, I'm pretty sure you've heard the term static electricity before, right? You're walking on your carpet, just walking on it, and then you touch doorknob and you get zapped. Well, the reason why is here we have your legs, okay? You're walking down it, okay? Now, when you're walking down, your feet or you are slowly becoming positive charged. And the reason why it is becoming positive charged is because all the negative charged ions are just leaving to the carpet, okay? Reason why, so let's start, because the carpet, the material most carpets are made out of, are materials that resemble an insulator, as we can see here. So an insulator is basically like an atom with it's like just like fully valence shell. So let's say we put it here, then it would have its nucleus and all its orbits, and it's mostly fully packed. So that's why they're just like hopping out, waiting for something next. Unlike you, or technically I, the one who's getting more positive charged, is a conductor. Okay, so like it's stuff, so the atoms on there have more room for electrons. So hence now it's getting like that, okay? So walking down, you're losing electrons to the carpet because it's an insulator, and gaining more, and well, having more positive charged stuff, becoming a conductor, which causes a charge imbalance. So now when you touch a door handle or anything, just metal in general, you just touch it. This happens because now, as we see, even though the door knob handle is neutral, it's at 0, it's basically a regular atom, it's at neutral, it is still a conductor, okay? So because of that, all like the negative stuff, because since the conductor side, all the atoms inside, they have a bunch of space, which means it allows for anything to leave, as we see here, but also to come in too. It's easy for both sides, which means that the electrons from here jump to your hand, okay? Because of that, giving you this sudden jolt, which creates a balance, because the world it will restore balance, okay? So let's put an example of them working together, okay? So such as a wire, okay? So the copper inside of it here is fully of copper, which is again a metal, which means it's a conductor, and the plastic outside is an insulator, okay? Now these help as it allows to the movement of electrons to move around, which now leads us to our fourth point. Electric circuits. This allows us to use electric circuits. So think of electric circuits as think of it as this. We have two squares, positive and negative here, okay? And let's say the negative side has these marbles coming down to the positive side. These marbles are electrons, okay? And this states here from our last time when we were talking about static electricity, as we know, that just proves that the negatively charged electrons, the negative charged ions, will just move the other side to the and get positive charge. So it just continues to do that. But most of the time, it's an instant that does it. So say, let's put an insulator in the middle. Bam, you do. That just cuts the circuit and like air, say, or put a plastic tube or something like that. It cuts it off, okay? Not allowing the electrons to move, so it just stops working, okay? And let's say we put something in it. So this is what creates electricity, because the electrons are moving from here into the object, say a light bulb, charging it up, giving it light, and then moving back. So it just continues to do that. Okay? So it just continues to do that. Okay? But now we should know this. Electrons are not spent. They still stay there. Okay? Which basically means that if doing this, you're basically risking a fire at this point, because sometimes a fire might just start from the circuit if you don't have anything placed like a light bulb or a TV. This will cause a short circuit, which means since there's no resistance to it, it just means that it's just moving, right? And it gets so hot that it just blows, creating a fire. Okay? That's why we made fuses. These basically just automatically cut the power if things get a bit too hot or high, okay? And that's basically what electricity is. And that's basically it. Thank you for watching this video. Hope to see you next time. Bye-bye!